Today we shall discuss regarding potassium dichromate, that is K2Cr2O7, potassium dichromate. First point, potassium dichromate is a very useful chemical used in leather and used in leather industry, and it is used as an oxidizing agent. It is used as an oxidant. Oxidant means oxidizing agents for the preparation of azo compounds. Azo means that nitro compounds, right? For the preparation of azo compounds, it is used as a oxidant. This potassium dichromate, that is K2Cr2O7, this 2 chromium, so that we call it as dichromate. So these dichromates are prepared. Let us go for the preparation method. These dichromates are prepared from chromate ore, FeCr2O4. So this is called as chromate ore. Chromate ore. So this is called as chromate ore. This chromate ore, first when reacted with sodium, FeCr2O4, when reacts with sodium carbonate, Na2CO3, in the presence of oxygen, it gives sodium chromate, Na2Cr4. This is sodium chromate plus Fe2O3 plus carbon dioxide. Let us balance this equation here. Fe2O3. Okay, oxygen 6. So here let us make 2 here. So in order to make it, let us make 4 and 8 and 7 and 8 here and 8. Let me write the equation again. So the sodium chromate is prepared from chromate ore. This let us go for preparation. Chromate ore. Chromate ore means that is FeCr2O4. This is the chromate ore. The chromate ore, when treated with sodium carbonate, Na2CO3 and oxygen, it gives sodium chromate, Na2Cr4, sodium chromate plus Fe2O3 plus CO2, right? If we balance this equation, it will be 4, 8, 7, and here 8, 2, 8. So this is the first method of preparation. That is, this is not the direct preparation. This is a chromate ore. This chromate ore treated with sodium carbonate. Oh, 7 should be here now. Plus 7O2. Chromate ore treated with sodium carbonate plus oxygen. Use sodium chromate and Fe2O3 plus CO2. This sodium chromate, this one, it is Na2Cr4. It is treated with an acid, and this will be a yellow solution. This will be an yellow solution. This yellow solution is filtered and treated with or sulfuric acid, H2SO4, gives sodium chromate, Na2Cr2O7 plus Na2SO4 plus H2O will give sodium chromate, sodium dichromate actually. This is sodium dichromate here. This is sodium chromate. This is sodium dichromate, right? This sodium dichromate, Na2Cr2O7, when treated with potassium chloride. So, as we know, NaCl will go away, NaCl will go away, and we can get K2Cr2O7. So, this is a required thing, potassium dichromate, and this will be orange in color. This will be orange crystals. This will be orange crystals, right? So, chromate ore when treated with sodium carbonate, it gives yellow color solution of sodium chromate, and then the sodium chromate is treated with sulfuric acid to use sodium dichromate, and the sodium dichromate is treated with potassium chloride to give potassium dichromate. Okay, is that clear? Take a screenshot. Yeah, here the chromates, no doubt, the chromates and dichromates, chromates and dichromates. Let me write like this. Chromates and dichromates are interchangeables, like reversible reaction. Chromates and dichromates are interchangeable. This depends upon the pH of the solution. This depends upon the pH of the solution. And here in the chromate, that's nothing but CrO4 2 minus, and dichromates Cr2O7 2 minus. In both the cases, the oxidation state of chromium is plus 6. It is also plus 6. 14 plus 16. 8 minus 2. So here x minus 8 is equal to minus 2. X is equal to minus 2 plus 8. X is equal to 6. Right? So here 2x minus 14 is equal to minus 2. But 2x is equal to minus 2 plus 14, that is equal to 12. So 2x is equal to 12 means x is equal to 6. So the oxidation state in both the cases is plus 6. And I said the chromate and interchromate dichromates are interconvertible. So the chromate, when it is treated with an acid, let me write the equation here. CrO4 2 minus. So this is chromate. This when treated with an acid, it gives dichromate Cr2O7 2 minus plus H2O. So if we balance 2 chromate and 2H plus, right? Like that, the chromate ion Cr2O7 2 minus, when treated with the base, it gives CrO4 2 minus chromate ion plus water. Again balance this equation. Cr2, so 2, OH, 2H, so 2. So that's it. So this is why I said the chromates and the dichromates are interconvertible. Chromate when treated with an acid gives a dichromate. This dichromate when treated with a base gives chromate. Let us go for the structures of chromate ion and dichromate ion. Structures. Here CrO4 2 minus. CrO4 2 minus. That is, it is in tetrahedral structure. CrO4 2 minus. CrO4 2 minus. So this is chromate ion. In the case of Cr2O7 2 minus, 2 chromium are there. These 2 chromium are bridged together. CrO, Cr. And each of chromium is bonded with 3 oxygen. Right? Like that of the tetrahedral joining together. Right? And the bond angle between these two chromium, that is 126 Armstrong, and here the bond length is 179 pm, right? So note these things. These will help you in EG exams. And here the bond angle between this chromium and this oxygen is 163 pm. This is 163 pm. This chromate ion is tetrahedral. This we call as a tetrahedral, and the dichromate ion, the tetrahedral, the end of the tetrahedral are joined together. So put together we have to write the structure like this, right? So if you are asked to draw the structures, this is the right thing for you. And next point, the sodium and potassium dichromates, that is K2Cr2O7 and Na2Cr2O7. These are all strong oxidizing agents. Remember, these are all strong oxidizing agents. These are all strong oxidizing agents. And instead of that, better than the potassium, the sodium has a greater solubility in water, and so that it is extensively used in organic industry. Extensively used as a oxidant in organic industry. And this potassium dichromate is used as a primary standard in volumetric. So this is a primary standard in volumetric analysis. In the presence of an acid, the oxidizing action takes place in the presence of an acid. How the oxidizing action takes place, or how potassium dichromate oxidizes in the presence of acidic medium. Let me write it in the form of equation. That is, I am writing the ion only. That is Cr2O7 2 minus. Right? When it is treated with an acid and electrons, it gives, that is the plus 6 is gets converted into Cr3 plus 7H2O. Then Cr3 plus in the means here it will be 14H plus. And the E0 value is given as 1.33 volt. So this oxidizes whatever it may be and itself get reduced. So listen here, this is in plus 6 oxidation state. This has gone to plus 3 oxidation state. Itself it get reduced and it oxidizes the material whatever it is having here. Oxidizing action. Oxidizing action. So you know that the potassium dichromate K2Cr2O7 and sodium dichromate Na2Cr2O7, both of them are strong oxidizing agents. Both of them are strong oxidizing agents. And this sodium dichromate is soluble in water, soluble in H2O, So that is used in wide range in the organic industry, in organic chemistry. Used as oxidizing agent in wide range in organic chemistry. And this potassium dichromate is used as a primary standard. It is used as the primary standard in volumetric analysis. Primary standard in volumetric analysis. Now, let us look into the oxidizing action of potassium dichromate. So, let me write the ionic equation Cr2O7 2 minus. So, this is the ion, right? So, this potassium dichromate, what it does, it accepts 6 electrons and gets converted into, or it's get reduced into Cr3 plus. So what is the oxidation state here? This is plus 6 oxidation state here. So plus 6, from plus 6 to it goes to Cr3 plus, right? It gets reduced by accepting 6 electrons. 6 electrons in the sense each chromium will accept 3 electrons, right? There are 2 chromium here. Each are in plus 6 oxidation state. Each chromium will accept 3 electrons. So we can get Cr3 plus here, 2 chromium, so that I'm making 2 chromium here. Right. So the number of oxygen is 7 here. So in order to maintain the number of oxygen, I'm adding water molecule. That is 7H2O. 7H2O. Here now, in order to maintain the hydrogen here, I'm adding H plus ion here. 14H plus ion. Right. So this is the equation, oxidizing equation, most important. This equation is a oxidizing action of dichromate ion, right? Whenever we are talking about the oxidizing action of dichromate ion, we have to use this formula. And here, the value of standard electrode potential is 1.33. What E naught value will be done here, right? So let us go for few examples for oxidizing action of potassium dichromate. It oxidizes, first one, it oxidizes iodides into iodine. Iodides into iodine. So iodides into iodine means, let me write a equation, that is 2I minus gets converted into I2 plus 2 electron. 2I minus gets converted into I2 plus 2 electron. So now, how does this happens? Let us relate with the oxidizing action of potassium dichromate. That is K2Cr2O7 2 minus. Hide these things. So this is not needed. So 2 minus, na? So this is not required here. So we try, it accepts 6 electrons. This oxidizing equation we have written before. It gives 2Cr3 plus 7H2O we had written. So in order to maintain the H2O, we had made 14H plus. So this is the action. So here, this is a reduction reaction. This is a reduction reaction. This is the oxidation reaction. This is the oxidation reaction. Right. So the number of electrons should be balanced on both the cases. The number of electrons should be balanced. Here 2 electrons are there, here 6 electrons are here. So in order to balance electrons, we are multiplying this equation into 3. So in order to make the 2 6 electrons. So this equation can be written as 6I minus gives 3I2 plus 6 electrons. Right. Now we can write the net equation. Right. So 6 electron get cancelled. So I can write the equation as Cr2O7 2 minus plus 14H plus 6I minus, that gives 2Cr3 plus 3I2 plus 7H2O plus 7H2O. This is the actual equation. Cr2O7 2 minus plus 14H plus 6I plus gives 2Cr3 plus 3I2 plus 7H2. This is the actual reaction. This we studied in redox reaction chapter. Redox plus 1, right? So this is how it converts iodide ions into iodine. Example 2. It converts H2S into sulfur. That is sulfur plus 2H plus 2 electrons. So here it is in minus 2 oxidation state. Na? It is in minus 2 oxidation state, S2 minus. So what it does, it gives away 2 electrons and become sulfide. This is sulfur and this is sulfide ion. So as usual, how it works, let us write the oxidizing action equation for potassium dichromate, that is Cr2O7 2 minus plus 6 electrons plus 14H plus, it gives Cr3 plus 7H2O, right? So this is a reduction reaction. So why it is reduction reaction? Here in plus 6, it gets converted into plus 3. Oxidation rate decreases, so it is a reduction reaction. And in the case of H2S, so here we can write S2 minus, it gets converted into S plus 2 electrons plus 2H plus. Right, let us write H2S itself. So here, this is the oxidation reaction. Oxidation reaction, because here it is in minus 2, here it is in 0. So the oxidation state increases. So it is the oxidation reaction. Now, we have to balance the number of electrons here. So 6 electrons here, 6 electrons here, 2 electrons here. So we have to multiply this equation into 3 in order to maintain the electrons. So it will be 3H2S gives 3 sulfur plus 6 electron plus 6H plus ion, right? Now cancel out this equation, that is this equation and this equation. So 6 electrons get cancelled, and here 6H plus ion, here 14H plus ion. So instead of 14, 14 minus 6, it is 8. So now we can write the final equation as Cr2O7 2 minus plus 8H plus ion plus H2S gives 2Cr3 plus 7H2O plus 3 sulfur plus 3 sulfur. So this is the final equation. Final equation. So this is how the potassium dichromate oxidizes the sulfide into sulfur. Sulfide into sulfur. Right. Let us go for one more example. Example 3. Fe2 plus to Fe3 plus. Right. So this is a third example. So let us write the oxidizing equation of potassium dichromate, that is Cr2O7 2 minus plus 6 electrons plus 14H plus, it gives out 2Cr3 plus 7H2O. As we know, this is a reduction reaction. Right here, the Fe2 plus, it becomes Fe3 plus by giving out one more electron. Now, this is the oxidation reaction, right? This is the oxidation reaction. Now, the number of electrons here is not balanced. Here 6 electrons, here only 1 electron. So multiply this equation by 6, which results in 6 Fe2 plus gives 6 Fe3 plus 6 electrons. Now cancel out the electrons, 6 electrons, and write the combined equation. Write the combined equation. C Cr2O7 2 minus plus 14H plus 6 Fe2 plus gives 2Cr3 plus 6 Fe2 plus 7H2O plus 7H2O. So this is a final equation. This is a final equation, right? This is the final equation. So these are the examples that how potassium dichromate oxidizes. The examples for oxidizing action of potassium dichromate. Next example, it oxidizes SN2 plus tin to SN4 plus. Right? As usual, write the equation, that is Cr2O7 2 minus plus 6 electrons plus 14H gives 2Cr3 plus 7H2O. So this is a reduction reaction. On oxidation reaction, it will be SN2 plus, it's get converted into SN4 plus and 2 electrons. Now this is 2 electron, this is 6 electron. So multiply this equation by 3. So it gives rise to 3SN2 plus gives 3SN4 plus 6 electrons, right? Now cancel out the electrons here. 6 electrons get cancelled. Add the equation and simply write here. That is Er2O7 2 minus plus 14H plus 3SN2 plus gives 2Cr3 plus 3SN4 plus 7H2, right? So this is another example to explain the oxidation action of potassium dichromate.